Good day, my viewers all over the world. I remain Saluma. Today, I want to welcome you to our subject, mathematics. Today, and under mathematics, we shall be talking about SohCahToa and Pythagoras theorem. SohCahToa, and Pythagoras theorem. SohCahToa and Pythagoras theorem. So these two principles are very vital, very important in mathematical calculations. And if you are in GSS2 down to SS3, there is no way you will not be working or not be talking about SohCahToa and the Pythagoras theorem. So today I want to tell us the principle, how it's being derived, when you are going to need be in need of it to solve mathematical problems. So let me start with Pythagoras theorem. Or let me start this way: that in mathematics there is something we call right angled triangle. So right angle triangle. So at least I think I've taught us about isosceles triangle. I've taught us about scaling triangle. I've talked about equilateral triangle. Please, you can check my videos on that. So, but you know that the sum of angles, let's say this angle A, B, and C. The sum of angle in a triangle must be equal to 180 degrees. That is, A plus B plus C must be equal to 180 degrees. But in a triangle, right angle triangle, one of the angles must be equal to 90 degrees. That is why when you see a triangle and you see something like a boss, you can see like a boss, it means this angle is what? 90 degrees. But they will not write it. They will just use this sign for you to know that it is what? 90 degrees. You know, this is a triangle. A triangle has three sides. We have side 1, side 2, and we have side 3. So the longest side where the hypotenuse is facing is called the hypotenuse. Where the right angle triangle is facing this line, which is the longest line. This is the longest line. So where this box is facing is called the hypotenuse. The longest line is called the hypotenuse. So the one that follows in size, maybe I put where I have the B, maybe I put an arc there. Where you have this arc is facing, okay, this after this line, what is next in terms of length is this place. So the arc will be here. I have the arc to be here. So where this arc is facing is called the opposite. And the shortest side is called the adjacent. So I want to prove this from Pythagoras. I said where the angle 90, the box, is facing, where it is facing is called the what? Hypotenuse. That is the longest side, hypotenuse. Following the longest side, we have this side. And this is where the arc is facing is called the what? The opposite. And the shortest side is called what? The adjacent. So Pythagoras gave us a formula that says that what? When you know two sides of a triangle and you want to determine the third side, that hypotenuse square, the square of this. So hypotenuse, this is shortened as I. Opposite is shortened as up, while adjacent is shortened as ADJ. So it now said that what? Hypotenuse squared is equal to opposite squared plus adjacent squared. That is from Pythagoras theorem. So for you to apply Pythagoras theorem, you must know two sides. You must be given two sides. Then you can determine the third side. For instance, maybe I give you a question like this. Maybe I now put this one to be 5. I put this one to be 4. If you now look at it, I will now put, let's say I now put this to be like this. So what I'm saying there is that the hypotenuse square from Pythagoras theorem, I want to determine this side. So in Pythagoras theorem, you don't talk about angle. You talk about what? Sides. Because that one differentiates Pythagoras from SohCahToa. So from Pythagoras theorem now, you say hypotenuse squared. Hypotenuse squared is equal to opposite squared plus adjacent squared. Always look at where the arc is facing. The arc is facing this place. So this is now opposite. So don't go and cram that because this one is hypotenuse, this one must be opposite. Just follow the arc. Where this arc is facing is the what? The opposite. So we have hypotenuse squared, which is 5 squared, is equal to opposite squared. What's the opposite squared? Opposite from this question is what? This is hypotenuse. This is opposite. Always label before you start solving the question. Then you have the adjacent. So it's the adjacent you want to determine. So we have opposite squared, that is 4 squared, plus adjacent squared. That is what we want to determine. So collecting the like terms now, we have 25 minus 16 is equal to adjacent square. So you have 9 is equal to adjacent square. So you take the square root of both sides. So you have adjacent is equal to square root of 9. Adjacent square, you know you are taking the square root. This will cancel this. You have adjacent to be equals to adjacent to be sorry. You have let me rub it. So you have adjacent squared to be equal to 9. So you take the square root of both sides. So you have adjacent, this will cancel this, is equal to 3. So this place is now what? 3. If you look at it, as we are doing all the solvings, you can see that I was not talking about anything like angle inside the triangle. All what I was talking about was what? The side. So for you to use Pythagoras theorem, you must know two sides. After you have determined the two sides, then through Pythagoras theorem, you can know the third side. But if you know just only one side, maybe you have this. 5. Maybe you now put 30 degrees here. You cannot use Pythagoras theorem. Why? Because it is only one side that is given. You don't have two sides. So you cannot apply Pythagoras theorem to this. Please get me clear on that. So for you to solve this kind of problem, we now talk about SohCahToa. And make sure that your triangle must be what? A right-angled triangle. So SohCahToa and Pythagoras theorem are strictly for right-angle triangle. And if I ask you what is a right-angle triangle, a right-angle triangle is a triangle in which one of the angles is equal to 90 degrees. And how do you connote 90 degrees? You use a box, like the way I used the other time. So for SohCahToa now, when you see so, I'm breaking it down. Toa. From the same principle I told you. Look at this. This is your triangle. This is your triangle. At least we should be familiar now. If I put the box here, or let me even change the position or the direction of the triangle so that it will be as if I'm just very rigid in what I'm doing. So it can be anyhow. So look at this now. And I put angle theta here. So theta can be any angle. When you see 0 with a dash at the center, it's called theta. So theta can be 10 degrees, can be 20 degrees, can be 0 degrees, can be any degree. So I have angle theta here. I have angle 90 degrees. Where is this one facing? It's facing here. Automatically, this one is hypotenuse. Where angle theta is facing will become what? The opposite. So the third side will be what? Adjacent. So from this, now we want to determine something. So at or when you say so, x means sine. You can complete it sine or you put sine. It means sine. While you're doing your calculation, you can write sine, sin, or complete it. So it says sine of this angle, theta, is equal to, what do you have here? O. O means opposite. All over H. H means what? Hypotenuse. So you can shorten this as sine theta is equal to opposite, OPP, all over hypotenuse. Because I told you that full length of ADJ is what? Adjacent. Full length of opposite is of OPP is what? Opposite. So this is the shortened form. If you see your textbook, so K, it means cosine. So cosine of this angle is equal to adjacent all over hypotenuse. All over hypotenuse. So it can be written as cos theta. This cosine theta. You can say cos theta is equal to what? Adjacent hypotenuse. You are still saying the same thing. So toa now, we have tan. That is tangent. So tan theta, tan of this angle is equal to opposite all over adjacent. In that way, we have explained SohCahToa. Now let's go to the application of this formula and take notes. Before you apply SohCahToa or Pythagoras theorem, your angle must be what? A right angled triangle. So let me give us something to work on now. Let's say this is a triangle. Let's say I have this. I can just draw like this. Maybe I now put 30 degrees here. Maybe I now put 5 here. I said find the value of x. In this kind of condition, first, how many sides do you have? You have just only one side. So it means that you cannot use Pythagoras theorem. Now you have one angle. Once you are given an angle and you have one side, automatically they are telling you to apply what? SohCahToa. And for me to solve this kind of problem, I will find a relationship that will connect a known side with the unknown side, like this. Let me label it down. This is what? Hypotenuse, because this box is facing here. The angle, which is this arc, is the theta, is facing here. So this is now the what? The opposite. So the third side is what? The adjacent. You don't need to cram, just follow the principle. The principle there is that wherever this box is facing is the hypotenuse. Wherever angle theta is facing is what? The opposite. Then the third side will be what? Adjacent. It's simple and straightforward. So what relationship is now connecting opposite and hypotenuse together? You now go to your SohCahToa. That where can I see in SohCahToa that will connect opposite and hypotenuse together? You now write sine, cos, tan. What is the angle? 30 degrees. 30 degrees. 30 degrees. What is sine theta? Sine theta is what? Opposite all over hypotenuse. Opposite all over hypotenuse. What is the opposite? X all over what? 5. X all over 5. What is hypotenuse? Sorry, what is cos theta? Cos theta is saying adjacent all over hypotenuse. Are we looking for adjacent? No. But if you are looking for adjacent, it means that this is what you are going to use. But they say you should find x. So automatically we are using sine 30 degrees. Assuming you are looking for, let's say we have opposite all over adjacent. Let's say you are looking for adjacent. You can also use tan theta. It will be what? Opposite. Do we have opposite? You don't know it. So you cannot use tan theta because you don't know two sides. in your formula. And that is this is what I'm saying. Opposite is what? Opposite is x, adjacent is adjacent. We don't know it. So these two unknown, you cannot solve this. So you cannot solve this. Though you can solve this as we are looking for this, you can do this. But here, what you want to find is what? X. So you have sin 30 equals to x all over 5. So by the time you do this, sin 30 is what? 0.5 or half. So if you are solving this, you don't need to write 0.5, just write half is equal to x all over what? 5. I will teach us how they derive at this half from that equilateral triangle. Please don't miss that video, ensure that you watch it. So cross multiply. After cross multiply, you have 2x is equal to what? 5. So x is equal to 5 all over 2. X is equal to what? 2 and a half. So it means this place is what? 2 and a half. Now you have gotten this place as 2 and a half. Now look at it. You can now use Pythagoras theorem to find this because you already know two sides. You can now use Pythagoras theorem to solve this, or you can go ahead and use SohCahToa to solve for adjacent. In our next video, I'm going to teach us on equilateral triangle. You can use this principle to solve any question. Just follow the way I've explained it. Adopt this principle, you are going to derive at your answer. My next video, I'm going to teach us how to arrive at sin 30, cos 30, tan 30 without using four-figure table. How to get sin 60, tan 60, cos 60 without sin 45, cos 45, tan 45 without using four-figure table. If you have not subscribed to my channel, please do so that you can always check updates, get updates of my videos. And for those who have subscribed, thank you very much for encouraging me. God bless you, and make sure that you please like this video, share it to others, not necessarily people in SS3 or SS2. Now I said I want my explanation to be very explicit so that those in GSS2, in GSS1 can also get benefit of my teachings. Thank you very much. I remain Salumaj. God bless you.